Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
For a potassium chloride crystal, any cube of ions contains 4 potassium chloride pairs, and these are the potassium and chloride ions, potassium being the positively charged one and the chlorine being the negatively charged ions. And then we know that each ion is part of 8 cubes. So each cube is worth, or contains rather, a half of one potassium chloride molecule. So we can think of the cube here and we can say that it has side length L, and we also know the volume would be L cubed. So we know that the density of potassium chloride is given by 1.99 grams per centimeters cubed. But we also know the density is equal to mass over volume, and in this case this would be the mass of one potassium chloride molecule over 2 lots of L cubed. And the factor of 2 has come in due to the fact that I've used mKcl as a factor of 2. So to make it even more clearer, I can put this here. So this is equivalent to 1/2 of mKcl. Now we need to figure out the side length. So we can rearrange for L, and we can say that L is equal to the cube root of the mass of one molecule divided by 2 lots of the density. Now the mass of the molecule, in order to work this out, we're given the molar mass, which is 74.55 grams per mole. And we make note of the fact that in 1 mole of substance, let's write down as the molar mass. In 1 mole of substance, we have 6.023 times 10 to the 23 molecules, right? So in order to get the mass of a molecule, we can put this all together and say that the mass of one molecule, where mKcl denotes this, is equal to the molar mass, which is 74.55 grams per mole. Okay, and we can divide it by the number of molecules in 1 mole. And you'll see that these will cancel, and then you'll get grams per molecule as units. Okay, so using this information, we can now work out what the side length is, and it might be better to use brackets. So now we have 74.55, which is the molar mass, divided by 2 lots of the density. And then as before, we've got the 1 over 6.023. And just to be even clearer, we can put in the units. So this is gram per mole, this is mole, this is molecules, and this is gram per centimeter cubed. So all these cancel, moles cancel, molecules is just a number, so we can ignore it. And then we've got a unit of length here in centimeters, which centimeters -3, which becomes just centimeters when taking the power of the bracket into account. So we're on the right lines because we know our units match. But when you calculate all this together, you get 3.15 times 10 to the -8 meters, taking into account standard form. And then this is equal to 0.315 nanometers.